Hi everyone, welcome to my daily edition 3, and in this daily edition I'll be explaining the math problem that was sent in to the group by Mrs. Pratt based on my outline and understanding of the formulas as well as help from the internet and outside sources. So the problem states that an amusement center charges $5 per ticket and averages around 200 visitors per day. So a survey shows for every 50 pence, I think, for pence and pounds, or 0.50 shekels. No, wait, pounds. 5 fewer people visit. So, for example, if the ticket price was £5.50 instead of £5, there would only be 195 visitors instead of 200. So my task in this DE3 is to find the price that maximizes the revenue that this amusement park is going to get. So firstly, I have to define the variables. So my variables, according to my research and my own understanding, is P as the ticket price, Q as the quantity demanded, as in visitors, and X, which is the number of 50 pence increases, which initial value is $5, 200 visitors, and 0 respectively, and the unit change is the ticket price increases by 0.50 per X, the visitors is decreases by 5 visitors per X, and unit change is 1, or X. So firstly, I'll have to create the demand function, which is Q multiplied by X. So in here, the demand functions is it models the visitors based on the price of the amusement park. So it helps us understand if increasing the price to this amount would be good. So fundamentally, according from my point of view, it tells me whether setting a $5 price would be good or a $10 price would be good or more. So the formula for this is the initial quantity equals 200, change in quantity equals 5xq multiplied by x equals 200 minus 5x, which is 5x is 0.5 pounds per x. So that's a $2.5 increase to 7.5 pounds. So next, we also need the price function, or the px, and the formula for this is the initial price, 5 changes in price, or 5 increases, equals 0.5 x, px equals 5 plus 0.5x. So we have to take the original number and take it in and then multiply it, and then I get the number. So the third step, according to Mrs. Pratt, is to find the revenue function, the Rx, which the revenue function is the price multiplied by the quantity. So it helps me know how many items were sold, how many tickets were sold. So this is Rx equals Px plus Qx multiplied by px, and then multiplied by rx, equals 5 plus 0.5 pounds multiplied by 200 visitors minus 5x. So I think that this formula is talking about how the price relates to the number of visitors. So as my research indicates, 5 plus 5OX, that's the ticket price, and the number of customers or visitors that come is 200 minus 5x. And if I look back at the formula chart I made, x is decreases by 5 for every 0.5 pence. So that means that 25 customers go if we set this price. Next is to simplify it. So firstly, according to my research and a bit of my own knowledge, I need to expand the formula and then simplify it to like a simple like equation. So it's R equals like, so basically it's 1000 minus 25x, or like I think that's like 25 0.5 increases, and then plus 100x minus 2.5 multiplied by 2. So I think what this is that it helps me like determine like the financial cost of like adding customers. Like if I charge $10 for 200 customers, and like I add like $10 to like the price, like 20 bucks, but only 190 people come, that's still like a profit increase, because it still like increases my revenue. Although comparing it to the original, the new version would have like more profit and revenue than the original, because it increased its price while not deducting its customers too much. So the simplified equation is 2.5 multiplied by 2 plus 75x plus 1000. So the fifth step is to maximize. So according to my research, there's like two methods of using this, of doing this, both of which I do not know and do not have enough time to do it. So I just like plugged it into like the calculator, and then it just showed the thing for me. So it's calculus and the vertex formula. So the one I chose was the vertex formula. So the vertex formula states that x equals 2a minus b for Rx equals negative 2.5 multiplied by 2 plus 75x plus 1000. We have a minus 2.5 and a b equals 75. So x equals 2 and in parentheses 2.5 minus 75x equals minus 5 minus 75x equals 15. So I don't really understand like the concept behind the vertex formula, but I still understand the concept of like the revenue maximization, which is like trying to like increase the price as much as I can without losing too much revenue and still making more profit. So according to the vertex formula, the maximum revenue occurs when there are like 15 price increases, which is around increasing like $7.5. So the final answer, since $7.5 pounds plus into like plus 5 pounds equals 12.5 pounds, I think that according to my research, calculations, and own knowledge, the price that maximizes the revenue that this business is going to have is 12.50, like 12 pounds and 50 pence. Yes, so that's my answer. Thank you for listening. I kind of struggle on these formulas because I'm not really good at them, but I still understand like the basic and fundamental concepts of like revenue maximization, and I understand how it works. I understand what it does, and basically understand how to implement it into my business, like on like a really basic level. So that's all for my DE3 this week. Thank you for listening. If I had any mistakes, please correct me, and thank you for listening. Bye.